Hello everyone, my name is Abbas, Technical Ambassador at Optimum. Welcome to my first tutorial. Today I will be setting up a local Optimum mesh, connect the nodes and experience Moon peer-to-peer in our local test environment. Before we start setting up the mesh, let's explain what Optimum is for those who don't know about it. Optimum is a decentralized memory layer for blockchains. It moves data faster and more efficiently by reducing redundancy. Instead of broadcasting full messages, it sends like gossip, it sends the coded shards that peers can recombine and decode later. So it's a memory layer, let's say, for blockchains at this point. So the way Optimum achieves this is through RLNC, which is random linear network coding. And the brain, let's say the mind behind of this technology is Muriel Medard. She's one of the co-inventor of RLNC, and this RLNC originated from MIT research, pioneered by the professor Muriel. So, in general, what we can say is Optimum, compared to the gossip, it takes the message, then splits into k chunks, then makes coded shards from this. And then the receiver side, as soon as it receives enough of these coded shards, it's able to decode the message. So in this case, we are avoiding spamming the traffic where there's no need to send the duplicate messages, right? Okay, maybe we can start also checking a little bit the website. So starting from the top, you will find the communication channels. You can join to the Discord and feel free to chat with the community. We've really got a good community that is pretty active. You can find also documentation, and you can also follow Optimum through their X channel. And there's also the validator sign up, where you can sign up as a validator to test Optimum's technology. Let's a little bit scroll down. Yeah, Moon peer-to-peer is the one that we will be doing today. We will do a local testing. Optimum DRAM will be coming soon. As soon as it arrives, I will also try to create local testing environment as well. So it's being cooked, let's say, at this point. And Muriel Medard in this video is explaining about how random linear network coding works. Feel free to watch in your free time. And we will probably see some testimonials from some partners, the Optimum team. Here we have the Professor Muriel Medard, Dr. Kishore Konwar, co-founder, and we have Kent Lin, another co-founder of Optimum, and advisors. So let's not skip the people that has been mentioned, right, guys, to be fair. So we have here Professor Nancy Lynch and Professor Sriram Viswanas. I hope I spelled it correctly, guys. Okay, let's start. I will go back to my article, which I published it some days ago, where I also did a little bit introduction about Optimum. And here you will see the proxy way and direct communication. We will do scenario A. Okay, Medium says, feel free to subscribe for updates from Abbas. Yeah, you can also feel free to subscribe, guys. So we will do scenario A, where we will do proxy testing. In this case, we will subscribe and publish messages with the help of proxy. In this case, we will I will show how this can be done, and then we will do scenario B, where we will do direct subscription and publishment of the messages, where we will not use any proxy. For prerequisites for the guide, we will use a laptop. Of course, we need a laptop for this tutorial. In this case, I'm using silicon-powered Mac. For Windows operating system, I haven't personally tested, but I'm expecting that it should be the same if you have the VSL with Docker desktop running on your Windows. That should be useful to follow up with the same commands that I will be using on my Mac. maybe if it's needed, I can also try to recreate the same environment through Windows operating system. You will also need a Docker desktop. Docker is basically, it lets you to ship an app with everything it needs. So inside it will have the code library and system tools. So it's all inside a container. Then you will need Git and Go. This one already inside the script that I will be showing. You can just run it. It will install the necessary things that's needed for achieving our goal, and of course the terminal or your preferred code editor. In this case, it's easy, or let's say easy to demonstrate through the terminal. We can open terminal A, terminal B, and see how things are moving. So let's start with scenario A. In scenario A, we will use Proxy plus Moon peer-to-peer, where we will have 2 proxies and 4 nodes in general. We will be using a env file. Env is a simple text file that stores configuration values. So you will see what information that we are basically storing. In generally, when you build a project, you usually keep env outside of your repository because it usually keeps sensitive values. Since we are in the local testing environment, we don't care. I don't care much. So let's start, right? What we will do is basically copy paste the things. The first thing I will do is copy this lines of code. So if we maybe go one by one, you will find here the cluster ID, the proxy version, and the bootstrap peer ID. We will later feed the bootstrap ID to our env file. In this case, the nodes will be able to communicate with each other. For the time being, this is empty. Okay, so let's now run this code. This is the one that we will be using, and this will basically write the bootstrap ID to our env file. We are installing also the Optimum files through the git clone from the Optimum's GitHub page. As you can see that we have now the peer ID here written. So we will, through this code, we are basically putting this information back to our env file where we specified here. Now we will use our compose file. The compose file that I will basically go one by one. So proxy 1, proxy 2, we will have 2 proxies, and the entry point we will do subscriptions through HTTP, VS, and gRPC. Then we will have 4 nodes. In this case, nodes 2, 4 we will use for bootstrapping to node 1 using bootstrap peer ID. Prometheus and Grafana. Prometheus is data collector. Let's say it's scraping the data and collecting the data, and Grafana is a visualization of this data. So Grafana is for dashboard, right? Prometheus collects the data and Grafana displays the data in a fancy way. In the future tutorials, I'm also thinking of creating a local environment where we can see how things are being demonstrated through Grafana. The Docker Compose, this one we will basically feed the information. Here there's pretty much information, but for the time being that we just want to achieve our goal and see how things work, I will just straightforward jump to optimum mesh target and tilt optimum threshold. Optimum mesh target 6 means that we are aiming to keep 6 neighbors connected. Maybe I can go with the top one. Yeah, this one. So here we are saying that the biggest message the node will accept is 1 megabyte. Then we are targeting 6, meaning we are aiming to keep about 6 neighbors connected. Then optimum mesh mean 3 and max 12, which means we don't go below 3 neighbors and we also do not exceed 12. An optimum shard factor for this basically is splitting each message into 4 parts. So these are the RLNC parts, I will say, before sending the message. And K4, okay, and optimum shard multiplier 1.5. This works in this way. For instance, we are putting 1.5 multiplied with K4, which means we have 6 shards in total. And optimum threshold 0.75. This basically means that once we start allowing decoding, when we've got 75% of independent shards which we are sending, once we send the message, and then as long as we have 75% of the independent shards, then we are able to decode the message. So with K4, in this case, if we have 3 good shards, then we are able to decode, where it's mentioned here as a 0.75. For now, let's do this. Let's copy this code. Also consider that this is my first technical tutorial. I may also need to read and learn more about Optimum and documentation, considering this is I've done just for seeing how things work in the terminal side, without too much understanding maybe the backend, but I hope it's something interactive and useful for you guys to watch. I will be copying also Prometheus. I'm thinking that in the upcoming tutorial we can see and debug or see how the visualization of things are working through the help of Prometheus and Grafana. We will start now everything. Before we start everything, we need to make sure that our Docker is up and running. Right now it's closed, so I'm gonna open my Docker desktop. So this is my Docker desktop. As you can see, there is no information. It's pretty empty. It's clean. I will now copy this part of the code and then I will paste it. So this will start pulling the information. So it's pulling node 1 for basically all the information that we have fed on the previous file. Now I'm also going to open the Docker desktop here. So while this is ongoing, you will realize that it will be filling all the necessary information we need for containers, for images, and for volume. Okay, I'm currently connected through hotspot, so a little bit slow. Sorry about that. Okay, it's all created. Nice. We can now see that we have in the containers Grafana, Prometheus nodes all are up and running. I can maybe maximize and then we can see the information here. So 2 proxies, 4 nodes, Grafana, Prometheus, images. We've got the node proxy, Prometheus, Grafana, and volume. Next stage, we can run this as well. It will basically show the proxies are alive and via HTTPL's endpoint. This will show my CPU, disk used, memory used, etc. And then we will copy paste this part of the code. So here we are opening the port for 33212. Now you will see that for node 1, 2, 3, 4, we have the port 33212 open. this is pretty, let's say, important for us to do the communication. And we will install the Mon peer-to-peer client. So this client, guys, I will say it's useful for let's say the app level tests where we can send and receive the messages. What it basically does is it lets us to publish and subscribe to topics via proxies. So we can call Mon peer-to-peer in this environment as a command line client for Optimum's Mon peer-to-peer proxy, right? I believe I didn't install it yet. I guess let's clear the terminal a little bit. Okay, let's wait a little bit for it to be completed. Verifying installation. This is my local admin password. Okay. Next we will do the test. First we will open terminal A, where we are going to be listening for a message from proxy 1. I will clean and I will use this terminal as terminal A. Right now we are listening for a message, so we are subscriber. In the terminal B, we will be publishing the message over HTTP via proxy 2. It is pretty important also to check the topic, because the topics needs to be the same, because if you are in a different topic and you are subscribed to Optimum community while you are publishing the topic from different topic, then the subscriber won't receive the message because they are basically in the different topics. They don't communicate. In this case, we will open the terminal B and run. As you see, the information that I pasted here with topic Optimum community, where with the message hello world, it's been published here in the subscriber. So in this scenario, we actually used RLNC, but we don't see it here at this point. In the future sessions, I'm thinking of enabling the logs and show you the piece of the RLNC. However, when we do direct connection, direct peer-to-peer, it should be showing some information that I can demonstrate. We will also do messaging by proxy, so gRPC. We will open terminal A again. Okay, now we are listening again for the message, and then we will be publishing the message. It doesn't matter, I'm gonna use again this terminal. Let me do again. Alright guys, as you see right now, I don't receive a message, right? So I've published a message, but the subscriber is not receiving it. First thing, we have to understand what's ongoing. There is definitely a communication issue here, I believe. What we can do to understand what's happening, you can go back to my article and we will use this code. This will basically pull the recent hints about bootstrap and discovery and errors, so we can see what's ongoing here. I will run this and maybe a little bit extend so we can see. So we have error here. Error advertising, failed to find any peer in the table. What I usually do is I always search, it's already written here, I always search for a mismatch, where we will see saying that there's a peer ID mismatch, right? Peer ID mismatch expected. This, however, the remote key matches is a different one. So this peer ID, as you see, is not matching with the one that we have here. The first 6 letters usually is the same, but the rest, as you see, is different once you compare. What we means that we now have to take the node 1's bootstrap ID and then publish it back again to all the other nodes, so they are aware of the new they are aware of the node 1's bootstrap ID in order for communication. So let's copy this part of the code. This is basically what it's going to be doing. So here you can see that the script that will provide, this is for the different scenario, but we can also relate it with this one. What this code will do is it's going to read the node 1's current peer ID from the logs, then it's going to update the env file which we basically created initially, and then restart nodes from 2 to 4 for us to test. Okay, I'm going to paste it, and here, so now we have the node 1 current peer ID which we see here, and then we have the containers that are all running. In this case, we can maybe go back again and do the same again. Okay, I think now we should be good. Let me search for success. Okay, so the successfully connected to Bootstrap node. In this case, I will say we are good. We can now go back to our scenario 1, where we were doing the test for gRPC. So let's again open terminal A, and let's also open terminal B, and then let's start doing our test. So this one is going to be for listening, while we will now use the publish for publishing the message, and let's see if that fixed it or not. Here is, as you can see now, the issue has been solved. We published the message, and then we have received the message. So this was the tutorial for a proxy way of doing the subscriber and publisher method. Now we will do direct peer-to-peer. Also, you can also see that we don't use any authentication, so we have temporarily disabled authentication for us to show this in the local testing environment. In scenario 2, we will not use any proxy. We will only use nodes for subscription and publishing the messages. But first we will stop the proxies. Let's stop the proxy so we are sure that we don't use any proxy. Alright, so the proxy is stopped. As you can see, the connection is closed by server. Also, if you go to Docker desktop, you should be able to see in the container that proxies are no longer running. Okay, let me minimize this part, and let's use this code. Alright, I believe I have already done this step before, not this step specifically, but I've installed already the necessary packages. Now we will do a subscription through node 3, and then we will publish from node 3. So we don't have any proxies involved at this point. Okay, now node 3 is listening. It's time for us to publish this message. Alright guys, as you can see, no proxy, we are publishing message and we are receiving a message. This was the peer-to-peer, direct peer-to-peer. And now we will do something a little bit, let's say, one level above. In this case, we will do a cross-node test where we will publish on node 1 while our node 3 is going to be listening. So it's not going to be node 1 to node 1, right? Node 3 to node 3. So let's now copy this part of the code. We are going to be publishing a message, hello world. Our node 3 is currently listening. Let's keep it open and let's publish the message. And here is, as you can see, now we have the message is appearing here. What we did, as I said before, we published on node 1 and we received on node 3. Specifically in this one, guys, we can also see RLNC information, I believe, here, because here you see the coefficients. We have let's say the coefficient vector. So all these are basically the pieces of information that's been sharded and arrived to us, I believe. As I said, this is just for demonstration. I haven't dig too much into the details, but I'm definitely thinking of creating another tutorial. Maybe in the next one we can just try to understand every piece and see the logs and understand things way better. Just for the time being, for the demonstration, I think that's just quite useful and interesting to watch, right? Our cross-node tests are not failing because we already did troubleshooting in the initial step, so our nodes are able to communicate with each other. So the one more thing that we will do, which I've created in the article, is this one is going to be fun. So we will subscribe on node 2 and node 4, and then we will publish on node 1. However, while we're publishing, we will be sending 100 messages, and we will see the live action ongoing with node 2 and 4. And what I really like about this is while all this is happening, we don't see the back end, but maybe with the logs in the upcoming tutorial I will be able to demonstrate. It's incredible that all the things are being done, like, you know, splitting the messages into the chunks, and then doing the RLNC, random linear excuse me, I'm a bit excited, guys, today. So random linear network coding, and then the receiver is receiving not all the messages, not all the pieces, but some pieces, and those some pieces are enough to decode the message, right? All these things are happening while we just see straightforward the output. It's pretty amazing. So let me open the terminal again. In this case, let's close. Let's also clean the terminal. Let's clean this one as well. Okay, all right. So I will use terminal A. I will use terminal A for subscribe node 2, and I will use terminal B for subscribing on node 4. So right now I have two terminals with two different nodes are listening, and here I will publish the message on node 1, and 100 times I will be sending a message. It's sending the message, as you can see, guys, that the both nodes are receiving instantly. And here I think we have this coefficient vector, which is the sharded, I think, the information that I'm for the time being, as I said, I'm not able to explain in detail, but I can just demonstrate you for now, but later I will probably deep dive into each line of the code to demonstrate you in the upcoming sessions. I'm also thinking of maybe creating a dashboard where we can collect the data from Prometheus and then visualize it through Grafana. That's also something going to be fun. And yes, if you want to try everything from scratch, you can also use this code. Basically, Docker desktop, while you have the containers running, it's not going to be sometimes easy to just delete from here because it still runs in the backend. So if you want to just force delete all the information from your Docker, you can basically use one of the terminal and then paste the information. It will now remove all the information from your Docker desktop. In this way you can again start from the scratch and then do all this procedure. Meanwhile, if you have any questions, feel free to join to Optimum's Discord channel. My handle is AbbasTFU. I have already mentioned here. Follow also me if you want, on X. I will be publishing more information, articles or tutorials as long as I have enough time. And yes, also if there's something that's maybe I'm unable to answer, feel free to reach to the team, so they might be able to help you. I wouldn't say might be, but they should be able to. So. And the references I've used, the documentation from Optimum website, the GitHub of the Optimum, which I've used as a reference, and to make things in a sequential way, to make it a bit clean and tidy. Also, to clean some bugs or some things from my side which was not configured properly. I've used ChatGPT also, so let's also give credit to AI, right? It's these days almost everyone is using AI, but it's also good for speeding up things. And the links for Optimum, if you feel free to subscribe to Optimum's X channel, where I've already placed here. Then you can also join to Optimum's Discord channel. Feel free to engage with our community. It's pretty active, I will say. We also have tech chat channel. If you like tech kind of conversations, or if you have any questions regarding the article or the tutorial that I've provided, feel free to ask there as well. And yeah, that's it, guys. Thank you so much again for taking your time and for watching the tutorial. It's Friday, probably in each part of the world. So have a nice weekend, and see you in the upcoming tutorial, right? Take care. Bye bye.